Question number 1. Consider the molecules below and determine the total number of motional modes as well as the number of translational, rotational, and vibrational modes respectively. For question A, we have CH4, methane. So to determine the total number of motional modes, all we have to do is use the formula 3N, where N is the total number of atoms. The reason we do 3N is because each atom has the ability to go in 3 directions, X, Y, Z. So that's why we do 3 times the total number of atoms. Now in this situation, be careful not to use 4. Many people make the mistake of seeing methane, they see the number 4, they think that there are only 4 atoms. However, do not forget the central atom. So it is actually 3 times 5, so 15 total motional modes. Okay, now to calculate the number of translational modes is easy because most molecules have 3 translational modes. So for our purposes, all these molecules will have 3 translational modes. Now if the molecule is linear or nonlinear, now this will affect the number of rotational modes. So methane is a nonlinear molecule, right? It is tetrahedral. That means it will have 3 rotational modes. Linear molecules will have only 2 rotational modes. So to calculate the number of vibrational modes is just to subtract the total number of translational and rotational modes from the total number of modes. So we have 15 minus 3 minus 3 is 9. So we have 9 vibrational modes. Okay, so let's move on to the next molecule. So now we have water. So water, it is nonlinear, right? It's bent. So let's note that. Okay, it has 3 molecules, so 3N. So that gives us 9 total. Again, there are 3 translational modes. There are going to be 3 rotational modes because it's nonlinear, and therefore there will be 3 vibrational modes. Okay, HCN. So what is the structure of HCN? So HCN, the structure is like this. Is this a linear molecule? Yes, this is the linear molecule. Therefore, again we do 3N. That will give us 9 total. We will have 3 translational, as always. However, this time we will have 2 rotational. Because it's linear, there's only 2 rotational modes. So that leaves us with 4 vibrational. Okay, so now we have HCl. HCl is also a linear molecule. So we have 3N. That gives us 6, 3 times 2. Okay, we will have 3 translational modes as always. We'll have 2 rotational modes, and that leaves us with 1 vibrational. And SF6 is definitely nonlinear. So SF6 will have 3N, so that gives us, so 7 is not 6, it's 7. So 3 times 7 is 21 total. And therefore we have 3 translational, we'll have 3 rotational, and that leaves us with 15 vibrational.